Alright, should be videoing, see how it goes and such. Maybe a short video, short-ish, who knows, we'll see, and such. Pop out the chat. Alright, did that, and then we'll move along to the subject. Draftphysics.com, video presentation, by the way. Alright, so, where the hell did it go? The Walter Lewin experiment. So, anyway, so this was, part of, in the argument, this was a discovered experiment. So after I realized kinetic energy was crap, you go looking for all of these experiments that are supposed to be demonstrating some form of transfer of energy from one thing to another. And in searching for those, this Professor Lewin experiment came up. It has this bizarre outcome where he actually creates free momentum by actual design. That's what the math says happens. And it seemed insane to me that this is an actual experiment, that this is an actual result, that this is an actual theory they believe in, all of those things. And so in observing the experiment, certain things became sort of obvious, like this blob of clay here. But then other things aren't so obvious in terms of figuring out that these carts can't possibly weigh what he claimed them to be weighing. So here he's doing an experiment. He's got the tape measure reversed for whatever reason. Well, he's using timing gates, so, but it'd still be nice to have. And so this little cart is supposed to be 1/2 the mass of this bigger cart. And the problem is that you can't make that work, in terms of logic, just observing the two carts. It seems clear the heavier cart doesn't have enough little things stuck to it for it to possibly weigh twice as much. And so Brozo has gone to the trouble to make at least one video. Well, he made a couple of videos actually trying to debunk the Mythbusters video where momentum was conserved and kinetic energy was ignored because it is irrelevant. It doesn't mean anything. But he hasn't in any way responded in any way I could understand to the contention, except to say that this clay is irrelevant. Somehow it doesn't have any mass. It's an insignificant amount of clay. Yeah, it's on both sides, let's assume, by the way. But yeah, he won't point out how, we can all state, kind of fairly that this is hard to believe that this cart could possibly weigh half as much as this cart. It's got to weigh more than half, and therefore that's how he made the experiment create free momentum, is that he basically changed what went in so he could change what comes out, because it can't work as a theory. The experiment doesn't have any theoretical ground to stand on. And the very fact that Professor Lewin teaches this crap and then fakes experiments to demonstrate the crap isn't a badge of honor, frankly. So this was initiated by the fact that this Falwell kook has made some kind of video, right? And the video, you just look at it and you're saying, what the fuck is this shit? So there's no description. It just says cycloid. Who cares? Cycloid. So, yes, and so what you really have to do is watch that very beginning part where you see him standing there. So the light shows the person, and he's just rolling a ball, a wheel with a light on it in one place. And this is, but you don't know that when you first watch the video. You're saying, what the fuck is that? You roll it one way, and it rolls back. Wow, that's really weird. That's not what's happening. He's just walking along with it, rolling it back and forth. Yeah. So at first I was like, what the fuck is this? How do you get these different velocities? The velocities aren't even consistent. It slows down, it speeds up. I mean, what the fuck is this? So this is the way they do science. It's all mystery crapola. You don't get to see how they do the experiment or what they're doing it with or any of that crap, that somehow this is helpful. So he did this video as a response to Professor Lewin's Little comment that he did it a different way. He was suggesting you move the camera, just have a wheel turn with a light on the outside, and then just move the camera, and you can create the same effect. Who cares? This is really unremarkable physics in the sense you're just rolling a wheel and you're saying yes, the light will bounce across the surface. Yeah, it doesn't have much of a choice. Because you're moving in two directions. The wheel's turning and the motion is in a direction. So there's nothing about this that's, in my opinion, at all interesting. But anyway, so that's the origin of the thing. And then I read he left a comment, and Lewin actually responded with something like super or whatever. I guess he commented that he made this crap video. And so instead of commenting like, well, why did you in one of your lectures fake an experiment? Obviously, they're afraid to take on their little heroes. But he made some kind of gushy comment like, oh, you must have had a marvelous life being all this interesting science and blah, 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 blah. This blowing smoke bullshit. And again, it just should be stated that, he did... violate the rules of one of the first rules of being a teacher. You don't try to molest your students. That's how dedicated to the science he was. He was a little distracted, but anyway, by the bullshit of whatever perks you call them. I guess perks of the job. Attempted perks, but forbidden fruit, so to speak. Anyway, so I just thought I would go over this again, just how, this is what science has come down to. So we don't have any of these experiments, so let's just understand. So they've had 350 years since this kinetic energy theory to show us this extra energy working, to show us a bullet producing 2,000 times more wattage than the recoil of the gun. The recoil of the gun is stated to have this terribly tiny amount of energy. The bullet has this insane amount, 1,000 times more. We don't have an experiment where they collect the wattage, okay, and show us the 1,000 times difference. 1,000 times difference amounts of energy. I mean, it's a huge difference. They should be able to show us this difference in some real way. We don't have simple experiments where they just compress a spring and then launch objects of different masses and see how much energy they have, how much velocity and mass they create. Because they're arguing that somehow they don't do exactly what you would expect, which is produce exactly the same momentum every time. The heavy thing goes slow, the light things go fast, proportional to the differential in their math. That's what he'll actually say in videos. And then he'll do this video showing something completely different. So he'll say, yeah, nature can't finagle momentum, and then he'll do this finagle momentum experiment. It's only one experiment. Yes, all the others conserve momentum. This one doesn't. But it really is critical to their fake energy theory that they have to force this to happen somewhere. They have to show energy transfers, and he can't do it with a lever, so he has to do it with this air track because he can finagle. Professor Lewin can finagle experiments. That's the truth. That's what should be stated. I mean, this is an abomination. This experiment, if my accusations are correct, this is a crime. Okay, it's an MIT professor, and he's sitting there finagling an experiment to force it to come out consistent with a wacky theory. If that's true, people should be upset and disturbed that that's what science has come to. Okay, that you just cheat to prove a theory. You don't actually have to do meritorious physics. You can just state something's true, finagle, cheat an experiment, and then claim forever that it's the truth, when it's not the truth. Okay, it's not good science. There's nothing honest or honorable about any of this crap. Okay, and it just people shouldn't get away with it. And all these naysayers are just they're the ones that allow the criminals to get away with it. They're just saying, go ahead, cheat. Go ahead. Don't do the experiments. Don't prove your claims. Force the other side to prove their claims. So force the Darwinians to prove it every single possible way possible, but force the Jesus freaks not to have to prove anything. They're exactly the same kind of tyrant. All right. Same kind of bullshit artists, frankly. Liars and cheaters. And that's all they are. All right, so let's see if there's a comment. We might as well read it. Good morning. That's all I have to say. Well, it's not very helpful, frankly. But okay, whatever. Ugh, people, you really can't get out of the mechanical, trivial mindset. You're just so human. Ugh, yuck. Anyway, all right, so let's just go through it. If this cart is going to be half the mass, that means that this cart has to have twice of anything this one has. So the red stuff is the aluminum. I think Brozo would admit there's every expectation that this bigger piece is cut to exactly twice the size of this piece. So in red stuff, red aluminum, they have the same amount. I mean, this one has clearly twice as much. So that's going to be the only department in which it has twice as much. In every other way, it's not going to have twice as much. It's not going to even have any in some cases. So you can understand, okay, the aluminum is right. So if we just started with bare aluminum, we have 1/2 the mass, we have 1 full mass. So it works, it's fine. All right, but now we count the springs. And these could be 10 grams each. Each attachment could be up to 10 grams. So we're talking about a significant amount of weight overall. So this one has 2 springs. This one only has 2 springs. So it's missing 2 more springs. To be twice the mass, it has to have 4 springs to have twice the mass. So it's missing 2 springs. Okay. Then it has a weight. This one has 1 weight. This one has 1 weight. We assume the other side is the same because the carts really do have to be balanced. So again, it's missing 2 weights. Okay, two weights are missing. All right, so that's pretty bad, right? Because they probably weigh a lot, okay? And this one really has to have 2 of them to be twice as massive as this one. All right, so it's missing 2 weights. Man, that's just gigantic. All right, and then we have the photo detector. This one has 1 photo detector attachment there in the back, and this one has 1 photo detector thing in the back. Missing again, it's missing the second one, so another miss. All right, so instead of 1 and 2 or 2 and 4, no, it's not there. And then the magical clay strip. So it was a strip of clay that was attached down here. Now that was probably there to make the cart more stable. And they smooshed it, okay, up into a little blob here. And there's probably a blob on the other side. And so not only does this have just 2 clay blobs, no, it doesn't have any. So it's missing 4 blobs of clay. This one assumes has another one on the other side to make it balanced. This one's missing 4 blobs of clay. So I'm just saying it's a reasonable argument to say these carts did not weigh what Professor Lewin said they weighed. That the experiment was falsely premised and performed, and it created free momentum. That is, this cart left with 2/3 the velocity of the half-massive cart. So even though in another video he says twice the mass, half the velocity, or half the mass, twice the velocity, even though he asserts that emphatically in another video, not this time, half the mass, no, 3/4 the velocity, 2/3. 2/3 the velocity it leaves with. Meaning it gained energy. Okay, if the twice as heavy mass ends up with 2/3 the velocity, well, that's free energy. All right, so it comes out to a substantial amount of free energy when you consider the other cart goes in the opposite direction with some momentum. Then it really gets ugly in the sense you go in with 100 and you come out with 166. I mean, that's a lot extra energy you're making. Momentum, movement in the universe. And again, I don't know how these other people believe that energy as something other than masses moving in the universe. That's what energy is, a mass moving. And that's how you calculate the energy, is just how much mass is it, how much is it moving. The end. I really don't know how they avoid that as a key way of understanding what's going to happen in the universe. Depends on just saying how big is it and how fast is it going. Amazing. So we have very few experiments actually demonstrating anything. The ones we have are fudged and fiddled with. And this is what everybody else, besides me, I guess, is saying is good science. This is the way science should be. Science shouldn't prove its arguments. It shouldn't provide the visual evidence, the proof. It should just, the proving experiments, the demonstrations. It just should make the assertion. You should believe in Jesus, and this is basically, this is basically like a fake UFO photo or a fake Sasquatch photo. This is just garbage. This is worse than, I don't know if flat earthers are actually faking, data, but this is just, how low can you go in terms of bad science when you have to fake the experiment? And this has every sign of being faked. Okay. Yeah. So I think that's my point. Maybe I'll leave it at that. This goes back to, we get all these comments from mindless marbles and these other dumbasses making claims, and, that I'm cheating. Yeah, right. No, they're cheating. Kind of obviously cheating. All right, kind of obviously not paying any attention to important aspects of doing experiments and being clinical and careful, not misleading, all that kind of crap, and not to concede that this isn't what science should look like. You should be demanding more from science, and instead they're wallowing in demanding less. Let the amateurs do the experiments. Let's do them sloppy. Quick release? We don't need no quick release. That's all they're saying. They're just a huge endorsement for all this sloppy way of doing experiments. Bang things into something you actually know what the results are going to mean. You have some proof that the structure is capable of extracting the energy in an even, proportional way. No, just bang it into a cracker or a piece of flour foam or some other kind of crap. For which you have no physics or science understanding to say whether or not it's even at all. None at all. No analysis that you've extracted the energy in any kind of rational way. And that's what you're doing, is extracting the energy based on the fact of how much velocity is usually lost. That's the distance argument. In these experiments with an air track, you're not doing the find out how much energy it has, because you're not taking the energy from it. So you can't use the distance argument, because yes, twice as fast means twice as far, not 4 times as far. So I could probably do more on friction. It's just, everybody who talks about it as if it's a counter force. And, like there's some opposing force and all that kind of stuff. And it really isn't. Not until you go... it's only an opposing force in the sense that all interactions between objects end up being opposing. In the sense that if you can hit something, it means you're going in the opposite direction. You can't hit something if you're both going in the same direction. So if we concede that the forces are all going the speed of light, well, obviously the forces can't hit each other if they're going the same way. So they have to be going some opposing direction, some opposing portion of motion. So you could argue in that sense that everything is actively got pieces in it, and all the pieces are all browning, motioning, and that you could argue that at any one moment the only piece you're going to hit are the pieces that are browning motion in the opposite direction you're encountering them in. Yeah. And so the interaction is fundamentally going to be between things that are not going the same way. And that's the nature of friction, is just you hitting other objects that aren't going the same way as you. Not moving the same speed as you're moving in the same direction. And that's why you hit them. It's because they're on your trajectory and you hit them. And that's what all friction is made out of. Friction is just a surface that has a bunch of motion in it. And that motion is going to mean you're going to have some contact. Now I suppose this is almost a related video, so I could go to this other video and contrive a little bit longer video. Let's see, Newton's broken cradle. Okay, yeah, so this is this dirty garage guy, or whatever the fuck he is. I guess I have to go through this ad crap again. Whatever. Just so annoying. They're everywhere. It's gotten a little worse, frankly, but whatever. Alright, now go play the ad again. Yeah. Should have just reloaded the page, Gary. Should have done that. Alright. So, this is not... this is pretty easy to analyze and break down. But whatever, we'll play the video anyway, and... because it sort of makes the point.
This is a quick one, a very, very quick one. So, I have one of these. Quick. It's been sat on my desk forever. This is actually... was a present from someone. It's crap. But...
it's not really that
you can see how, it's a Newton's cradle. Everyone kind of thinks they know how they work, but it's not exactly how people think they work. But regardless, everyone gets the...
It's not exactly how people think it works, so that's just kind of a nothing statement. What do you think people think? I'd be interested to know how you think it works versus how they think it works.
Principle, right? One ball, that kind of thing. It's because these wires aren't brilliant, right? Spaced and all the rest of it. And then the usual, all right? Now, what we're going to do is I'm going to show you something, and I want people in the comments to fully explain the reason what's going on. It might
to fully explain
seem simple. Let's just get on with it, right? So what I'm going to do is I'm going to pull this out. I'm going to pull this out, so from this main bar, it's 5mm, and the only reason why I'm doing that, I'm using the lines behind me on this to line up with my eyes, basically. 5 centimeters out, not...
I don't know exactly, yes, it doesn't seem like the most brilliant way to measure. You should be measuring from the ball, not from the bar, so that's really stupid.
Millimeters, and I'm just going to let go from there. I'm going to wait until we stop hearing the noise.
So obviously they're just doing what a Newton's cradle should do, which is a fairly efficient transfer of the energy, because it's going, well, the speed and mass ratio is going to be the same for the input as it would be for the output. There has to be no conversion. So it's not like one ball has quarters or nickels and it has to make it into dimes to fit into the other object. So it doesn't have to be converted. So therefore the energy just moves at the speed of sound for the little period that it moves. So if you did this experiment where you just had one ball and you did the bang into it and it leaves. See, this should be already an experiment that's already done. They should have superimposed over each other the ball just moving all by itself, and then right below that an image of when it hits the other ball, how much it lags behind, because there will be a delay. That's tricky because the speed of sound is fast. In metal it's really fast, like twice as fast or 3 times as fast. So clearly it's going, but still it's still a delay. It still has to do that process. Instead of moving, it has to transfer the information at the speed of sound in the ball for that bit of distance. So that would be the lag that the ball that gets hit has. But otherwise, that's the transfer of the energy. It's a pretty smooth transfer. It doesn't have to bounce back and forth a bunch of times inside of the object to figure out how fast it can make it move. It can just go straight through. And so Newton's cradles work if the masses are the same. And then this is just going to get to the center of their mass, which, is kind of obvious. If you don't hit the center of the mass, then you're going to cause directions. So maybe I'll do that part just for the fun of it. I'll draw it instead. So I've always been asserting that anytime you lose energy. That's what you're doing. You're losing it. You're exchanging it with something else. And so the friction argument, the heat argument, it's all the same thing. Okay, all you're really saying is you have energy in a direction, little bits. And the idea is you have a system that doesn't have friction or air resistance or some other crap. And all you're saying is that everything retains its direction. So it just keeps going in that direction because you haven't lost any of the little bits in another direction. And that what friction is, okay, is you leaking. Okay, that is some of these little bits hitting in some way or hitting with something in some way where they start going in other directions. Okay, and when they go in other directions, you're not going to be able to see them as motion anymore because they've been lost as motion. All right. So when you contact something, when two things hit each other, they're basically going to share their information about which way their stuff is going. This one might have stuff going this way, and this one might have stuff going this way. And now they're going to interact, and the interactions are going to create even more scatter. Okay, so it's going to be more likely that the bits are going to be going in directions that you don't intend, and that you're going to lose more energy. So the less it's going straight. So this is another argument for velocity. So the faster you're going into something, the more likely it is, okay, that the stuff won't scatter because you'll dominate the exchanges. So when you hit something, the percentage of your energy versus its little energy, okay, will keep the track relatively straight. And that's the difference between something going fast, is that it can keep the momentum ahead of it, and something going slow, which means that the ratio of how much this thing is going to bend you starts increasing. So when this arrow gets shorter and these arrows end up relatively longer, then they're going to push you in their direction. And so the heavy thing is going to dissipate its energy in lots of directions, the heavy slow thing, where the light fast thing is not going to dissipate its energy nearly as much. And so it's able to penetrate further because it doesn't waste energy going in the wrong directions. Yeah, that's probably enough of that. So he's just basically going to illustrate that point, is that when you don't hit things on their center, right, then what are you doing really? Well, then you're hitting it down, especially if these surfaces require that the energy has to be perpendicular to the surface. So you had energy going this way, and you basically just converted it into energy going the other way because of, frankly, the surface problem. And so you took this and you just ended up doing this with it. Or you did this with it, if you hit below, and then you end up popping it up in the gravity, and then it comes back down out of the gravity, and you're just doing this to the energy. So you put energy in this way, and you end up converting it into a bunch of motion in the wrong direction. And so that's what will be illustrated here.
So there, right? That's however long that is in seconds, we'll use that, right? Now we could do a repeat, and usually if you're doing a proper experiment, you repeat this so many times to get an average. Not a maximum average, not a lower average, an actual real average. Now I've just got a hard case here. This is a hard case for lavalier mics and stuff like that. What I'm going to do is I'm just going to prop it up.
So you think he could have just counted how many times it went back and forth before it stopped clicking even, So he could have done something a little qualitative, but instead he was just lazy.
Like that. That's all I'm going to do. We haven't touched anything, right? And as you can see where level is. And we are 4 centimeters or 40 millimeters up.
Right, so the wires are all the consistent length and all that kind of crap, but there's obviously now, okay, the problem is that the little balls are hanging from a different location, so they're sloped. So now they're not hitting the center of mass. They're hitting this piece of the circle, it's hitting this piece of the circle. The perpendicular is now in the wrong direction. So instead of pushing straight through the object, it's hitting the energy at an angle. So it's really just putting more tension on the little pieces of fishing line, and it's also causing the objects to bounce more up and down rather than move forward. So the energy is now being deflected because of the poor angle of impact. So there's more scatter. You're scattering the energy in a bunch of directions that aren't the same as the direction you put in.
Oh yeah. Now what I'm going to do is, from where that wire is swinging, right? So from there, where that wire is swinging, which has to be to the bar, right? So about the...
So that measurement's just a little bit kind of retarded, frankly, because frankly he isn't measuring this distance in the first case, and so he is in fact putting less energy in. But who cares? It's not that much less.
Same amount, same ball. Let's see what happens now. And then it stops.
Right. And it stops because it lost all the energy to a bunch of motion in the wrong direction. Because the first motion coming in pushed down on this ball pushes down on this wall.
That was a hell of a lot shorter. So
and it's also it's probably got more swing in it, but I can't say for sure.
Let's find something. A USB adapter port thing. And let's jack it up even more.
A card reader, but whatever. Jeez. It's kind of nice to have one, you know. I had one, but just failed to continue working.
And now we're at 5.5, right? 5.5 centimeters up. Same dealio. I'm just going to grab this, swing it back from where it was resting, which is about there. 5 back, which would be there, right?
So the more the slope, the more off the center, the more... So if you went even higher, you eventually hit the top of this one, and you're just pushing it down instead of pushing it forward. And so, yes, you're just wasting a bunch of energy putting more tension on the plastic wires and other things. So, yes, you've dissipated the energy in the wrong direction. So that's all you're demonstrating, is that you can scatter the energy by not obeying the rules required for the energy to be conserved in the direction you wish to observe or conserve it in. Same energy, it's just that it was doing motions that you can't see. That's all it is. There's some motions you see and motions you don't see. Little fast up and down motions you don't see. Slow motions in a direction you do see. You know, that's all there was to it.
Why? Right? What is going on? And just for, you know, continuity's sake, right? Let's go from the bottom. Just come out 5 centimeters. I can measure it, but you get what I mean. It's about
so then he's just topping the first ball up a little, but you can see they're vibrating.
That's very quick compared to. I'm not going to touch it. I'm just going to remove that, drop that down.
So yeah, we already did this. So this is really unremarkable. It's kind of pathetic that he would do this experiment, say to his audience of morons. I guess he thinks they're all morons, that they can't figure out you're not hitting the center of the mass anymore. And if you're not hitting the center of the mass, you're not likely to have an efficient exchange of the energy. You're going to exchange it in wrong directions. So whatever. Let's see. Let's see what this guy says. When the frame is tilted, vertical forces are introduced into the ball. No, you're converting the horizontal energy into. Okay, you're not introducing them. You're sacrificing this for this. All right. When they are swung because they no longer strike each other in the same direction of travel. Well, it's not about the direction of travel. It's about the angle of the surface, frankly. But regardless, they strike each other at an angle, so the energy is lost into the wires. Downward force. Well, yes, the wires is what he's calling the fishing line. Okay. And some energy is lost into gravitational mass of the ball. No, that one doesn't happen. You don't really lose that. And well, you do lose it in the sense that, you know, theoretically it could go for a very long time, but it still is energy in the wrong direction. So it doesn't matter whether you're pushing down or pushing up. That won't get reconverted into forward. Okay? Once you start going up and down, you're just going to lose the energy to the up and down motion. Alright, can you please do a follow-up video explaining in a proper detail with, I don't know what this, I think he meant equations and stuff, would be loads of physics that could be applied to different things. I don't exactly know how there's loads of physics applied to this silly demonstration. I'm sure he will. That's probably why he's doing this video. You think? Huh. Yeah, I don't think so, but we'll see. I mean, it's so obvious, like, you know, it's trivial, frankly. You know. Let's see, there's less energy. No, there isn't. That is much as I can do. No, there's less efficiency in the transfer of the energy, and therefore there's energy moving in directions you don't see. Okay. You are fighting gravity basically, and the conservation of momentum is lessened as the balls are using this energy to travel upward. Yes, that's correct. So I don't know why you said it wrong there when you said it right there. Speeding up the total loss of kinetic energy. Well, there's no kinetic energy. That's baby talk. The balls are moving in an elliptical path and not in a straight line. They're not really elliptical either. Okay, but whatever. When they strike each other, and the angles they are struck is also reducing the energy conserved. So the energy is conserved, it's just being transferred to a different direction. So you're just essentially scattering the energy. Each ball striking off center and imparting some energy into the wires, but it's mainly gravity. I don't know about it mainly being gravity. I mean, the pushing down force wouldn't necessarily have much to do with gravity, in the sense that it depends on how elastic the wires are and all that kind of crap. But regardless, I mean, you're certainly not fighting gravity by pushing down on something. But clearly, if something's being suspended by a force that's suspending it, then you're fighting the suspension force. You're putting more pressure on the wire, creating more weight for it to be stretched by. It's about the vector of force. There you go. Yeah, the force vector will be scattered. Okay. When the frame is horizontal, the impact force of the ball travels in a straight line in the most efficient way. When the frame is tilted, the balls hit a bit forward and a bit downward. Yes, mainly because of their surfaces. Okay, looking from left to right. I mean, even if you did it as an angular momentum kind of argument, let's say the thing was square and the surfaces were always horizontal, so it didn't matter which way I turned it, I always made the surfaces flat. So then you'd be hitting the top of the mass. And so then the tendency would be to create this kind of wobble, which still has a component in this direction. So in a way, this wobble would be conservative, where this wobble is not. No, conservative is the wrong word. Would keep the motion in at least the same direction. So even though you're creating motion in this direction, you always are countering it with motion in this direction. So the wobble, you lose a lot less going this way than you lose going this way. This way you're fighting gravity. This way you're not. All right. Alright, gravity is what is affecting the balls, and the change in angle did three things. Okay. When the base was flat, the balls on the outside traveled further horizontally at the start of the swing, and less energy is needed to get them moving. He measured poorly. I think that would be a good thing. Anyway, the energy moving right and left had the work against gravity, which absorbed some of the energy. The energy moving right to left had to work against gravity. So again, they're impacting at the bottom of the gravitational slope, so there's no working against gravity. Obviously, the energy is being created by gravity. So the ball swung away less and therefore had less distance to be affected by the gravity now. So yes, less energy went in merely because he did tilt it, and the distances are off. The impact, the distance from the point you drop it to the point it hits isn't the same exact gravitational distance. So you wanted to go, how high am I above the point at which he's going to hit the balls? But again, his measurements were so crappy that it's hard to make much out of it, because yes, it's just a given, his measurements were pretty crappy. But that really isn't the reason it's so substantially less durable. The reason why the energy is less durable is because every time there's a swing back and forth, there's energy going more energy is being put into the wrong way motion. So with every swing back and forth, more and more energy is being converted or scattered into vertical motion. All right. That's the simple. We'll just leave it there. All right. So there's a little bonus. Oh, you couldn't see the video. Anyway, it really wasn't that miraculous. So I'll just show you the static images. So there he's measuring, and this is really a huge distance. You can really see that's a really big distance. Anyway, and so then he does the experiment, lifted up one end, and now the balls are not hitting each other through the center of their masses. And then he does this crappy measurement, which is obviously a very different measurement. I mean, this distance is much less. So he didn't need to cheat the experiment, but he really did cheat it, by not creating the same velocity at impact. All right, and and that's all you got to see. It's just much shorter. You could hear the little tap tap taps, and you could hear it's much shorter. So anyway, and so that's normal, and this is abnormal.
With there, right?
Yes, runs
a
out of
lot
energy
quicker.
quickly. Yes, okay. So you could hear that, so it's good enough. It'll have to do. I'm sorry. I gotta keep track of what's visible and what's not on this stupid screen. Where the hell did the fucking... Where is the chat thing? It's gone. Yeah, it is gone. Why the hell is it gone? I don't know. So it says this device isn't even connected, which is weird. Huh. Can't make much out of that. Let's see. Can't be sure what that is. Well, we won't bother. We'll just put it back on the screen. It should show up again, right? I think so. Yeah, there it goes. Okay. Now we'll just slide that over here because that's what we do. Alright, in the Lewin experiment, doesn't conventional physics say the small mass reversing direction now has negative momentum? Yes, I'm saying the idea of negative momentum is fundamentally retarded. Energy is never negative. So anytime you have a mass and a velocity, it's never negative. You can't, if I hit two things and I'm going to make them go sideways, and I'm going to put the energy in this way, you can imagine that, I hit it with a round ball, I'm going to make these two balls go sideways. You can understand that I can't possibly say this is negative and this is positive, and therefore say there's no momentum. I'm clearly only going to be able to create, if this one's going 40 miles an hour and these masses are equal, these are going to leave at 20 each. I can't make more energy, I can't destroy the energy, and there's certainly no such thing as unenergy. So I'm saying that that's what my whole point is they're arguing for a concept that is fundamentally retarded. I mean, it's absolute nonsense to say there's such a thing as negative momentum, that something can be going in the negative direction, that it somehow is the undue direction, or the I can pretend I can subtract this amount from that amount and somehow that makes sense and I have zero action in the universe. You don't have zero action in the universe. You have, in the case of this particular experiment, you now have more energy in the universe than you started with when you did the experiment. And the whole 500-year-old Descartesian rule is you can't make more energy in the universe. Okay. Alright, negative momentum, which is why the big mass departs with more post-collision momentum. Yes, that's exactly their theory. I'm saying the theory has no grounds. It has no theoretical viability unless you believe in free energy. Unless you believe you can create free energy. Because that's the only way you could do it. Okay? Masses and velocities are exchanged. And you can't do the exchange in some way where I end up with more energy. That's not possible. And that's why this physics is evil. It's not just wrong or stupid. It's fucking evil that for 300 years they've been selling this notion of what energy is. That's a complete unicorn theory. It's got no viability. It's no theoretical viability. It violates their own rules all over the place. It's non-conservational. It's a duality. It's basically saying I have two answers to the question. Every time I look at a system, I can say, well, there's the kinetic energy number and there's the momentum number. And, you know, in any case where I do a transfer between uneven masses, those two numbers aren't going to match. And somehow physics says that's okay. I'm clearly saying that's crap. And then they use this vector scalar crap that they just made up. They just walked up to it one day and decided to call it a S word. You know, you're an S word, you're a scalar, and you're a vector. Yeah, and it's just a label. I mean, you know, it's a rudeness being committed against, okay, momentum and kinetic energy, because both of them are doing exactly the same thing. The kinetic energy of the train is exactly the same motion, okay? It's the same direction, it's the same vector, it's the same in one fucking direction as the momentum is. It's ludicrous to say its kinetic energy is magically mysterious, and somehow its momentum isn't magically mysterious. It's baby talk. It is shit. And people are selling it, and they don't have any evidence, real evidence to support it, so they have these contrived and fake experiments, and then these dopey amateurs show up and say, I'm going to prove free energy, you know, and they do their little wacky, dirty, filthy, shitty experiments and claim, well, look, the cracker cracked more. I mean, some sort of crap, you know, and say, there, I've proven something. No, all you've proven is you're liars and assholes. And that's why science is broken. It's because the audience is full of a bunch of fanatics, believers, fans. Yeah, that's the word to use. Fans. They're fans. They're Professor Lewin fans. I love you, Professor. Oh, can you live forever? Oh, baby, 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 baby talk, baby talk. It's terrible, frankly. Horrific. So, thank you. Insightful comment on the subject, mostly. Yes, I am arguing with the conventional theory. Yes, if you haven't caught on yet, that's what I've been doing for 10 years, actually, is arguing with the conventional theory. It's a pile of crap, an unproven, unevidenced fable of magical functions. Which levers and gears and cylinders, pressurized hydraulics, all prove to be unviable as a theory, because none of those things would work right if they could make free energy or destroy energy. But no one will say anything. No one will do anything. No one will support the argument. Like I said, I titled this video kind of rudely because I want to make the point. I mean, these assholes just keep defending this bad physics, this unevidenced crap. And, you know, there's you people, you're the only way, you know, the audience is the only thing that's going to stop them, okay, from cheating and breaking the rules and doing all this crap. And so if you don't catch them breaking the rules and call them on it, then they'll just keep doing it. They'll keep creating their cold fusion and their other bullshit. They'll tell you, we finally did it. We have above unity with their nuclear fusion, right? When we know that's not true. That it doesn't really. You know, the laser beam is so preposterously inefficient, you know, that you can't make. They're not making any extra energy. Okay, no extra. You know, they have a gigantic electric bill. You know, their energy plant. You know, their that's producing free, extra energy, obviously is doing so poorly that you could go broke really fast investing in it. Are you going for a physics degree anytime soon? I mean, why would I do that? I mean, obviously, I'm not gonna. It would be a very contentious. I would like, just as for fun, if I was a more outgoing person, I would, in fact, go to, a community college and take physics courses just for the point, just to raise these issues with physicists. But circumstances are circumstances. Everybody's got their own little life they have to live, and that's just not going to happen. But it would be fun. I'm certainly not going to go there and say stupid things like per second. Yeah, I'm not going to do that. I won't write that on any test paper. If we did the Lewin experiment, but suppose that in the absolute universe, so I don't know what you're doing this for, the post-collision momentum of both objects remained positive, whatever that means, does momentum conservation make more sense? I don't know what you're saying. Momentum isn't violated, okay? The experiment doesn't, if you do it right, it doesn't violate momentum. So the whole point I'm making is obviously he didn't do the right experiment. He sent a heavier mass, okay, not a half mass, and hit the object. So he didn't transfer 2/3 the momentum, in the sense that there isn't a free 133 at the end there, because he put the extra 33 in. Okay, the momentum already went in, so the extra 33 didn't exist in the one direction. And you do have to account for the reverse direction. So I'm just saying, if you do the experiment correctly, momentum will be conserved. There's a physicist from my town that won a Nobel Prize in 2015. Well, it must be a pretty shitty one. Yeah, well, okay, 2015, I have to go back. That's after, let's see, the LED one was around 2019 or 20, right? So 2015, I wonder what kind of silly thing that was for. I mean, they give, most of the Nobel Prizes are for crap physics, frankly. I mean, this year's prize was for the pretty much fake entanglement experiments. The Allen aspect experiment, which was never repeated, frankly. I mean, with his magical patented spinning mirror thing. Yeah, I wish I had a physicist around here that I could harass. Harass in a productive way. I could just walk by. I could walk my imaginary dog and could say something like, "Your physics is as, fake as my fake dog." See if I can engage him in a conversation. Yes, it is true. There's a small audience, and the audience is just a bunch of flag-waving patriots. They're just devotees of their little clubs. They really are gangs. The little gang of stringers and the little gang of whatever, dark energiers, and they're just little gangs of morons. Jointly, I love the joint prizes, and actually for the discovery of neutrino oscillations, which shows that neutrinos have mass. Well, you know, that is a whole nother argument that's just so silly. Obviously, they didn't do any neutrino experiment. This is all theoretical crap. It doesn't mean a damn thing to anybody rational. Yeah. So again, yes, see, the sun produces too much kinetic energy. See, that's the problem. Because they believe in mv squared, every time they convert a big atom into a smaller atom, they end up making free energy. See, because they're conserving the momentum, and they end up with free kinetic energy. So every time they make smaller particles, they have to come up with something else that was made, because that's the only way they can conserve their kinetic energy. So the neutrino is completely a byproduct of kinetic energy theory. It can't exist. If you believe in momentum, it doesn't exist. If you believe in kinetic energy, then it exists. I mean, it's that kind of a silly thing. It only exists because they had a mathematical deficit, and they just said, well, there must be some other secret magical particle that's carrying away the energy. So they invented the super fast little neutrino with the tiny little mass, you know, that they could give a big giant pile of kinetic energy to. Well, it is sad that they have decided that, you know, the physical universe is some sort of math formalization. And, you know, we don't come off, you know, as a math formalization. It doesn't, you're not going to get the truth. It's such a crude idea of defining what a something is. You know, something isn't just its mass and its velocity. Yes, that's its energy, but that isn't what the something is, and that's not why it's going to be affected by magnetism or it's going to be affected by charge. There's other aspects to the physics, and the math just tries to turn everything into a one-dimensional object and then give it, you know, these insanely silly properties. It's spin, but it's not really spinning, you know. I mean, what's the point? The magical spin property, whatever the fuck that is. Yeah. I mean, the concepts are more important, in my opinion, than being able to do the formal equation that calculates the, you know, to a measure of precision, you know, and that's all it is, a measure of precision. It's not actually the right answer. It's just the closest we can get to the right answer. I mean, that's all calculus is a demonstration of. Calculus doesn't give you the explicitly correct answer. It just gives you a really good guess. Your issue, it's, you know, whatever, however you want to describe this, okay. Yeah, I've made my issue kind of clear. Momentum is real, kinetic energy is a fable. Alright, with conventional physics explanation is the existence of negative momentum. Well, I'm saying if you believe in momentum, then there's no reason to have any notion that you can make such a thing as a negative momentum, or an unmomentum, or a reverse undid it momentum, or a redo or an undo momentum. Yes, all momentum has to be conserved, and it doesn't matter what direction it's going in, it has to be conserved. Anything moving, you have stuff moving going in, you have stuff moving going out, that conservation is real. It doesn't matter which direction it's moving, it just matters that it's moving, and it's a mass, and that has to be conserved. My experimental setup, I don't know what that is. My experimental setup ensures there is never negative momentum. I don't know what you're talking about, and I'm working if you still see a problem. What? My experiment setup ensures there is never negative momentum, and I'm wondering if you still see a problem. I don't even know what you're talking about. Okay, so all the way back to the stupid space thing. Let's see. Your issue, I just set up the experiment such that there is never negative momentum. So there is a problem with the setup. Oh, well, here we go. If Professor Lewin experiment, but suppose that the absolute universe, the post-collision momentum of both objects remained positive, does the momentum conservation make more sense? You can't do it with his experiment because the masses aren't right. So I don't know what you want me to say. The particular experiment he did is with not a half mass. So you're saying that there's more momentum going into the experiment. And yes, it still works in space or anywhere, that if he actually uses a half mass, okay, the argument is that the heavier mass will go away with much less than half the velocity, not 2/3, it'll be less than half, and the reflecting object will carry the difference. So whatever less than half the two mass leaves with, the other object's going to reflect with that exact amount of energy, and you will perfectly conserve momentum. So yes, if we can do the experiment in space, okay, I'm saying there'll be no such thing as this way subtracts from this way. No, this way is a portion of the total energy, and you have to add it. You can't subtract it. I don't know how to make it any clearer. A profound thing I learned is that having intelligence doesn't mean you go the route of intelligence. I'm just not, I can't, sorry, I have to react that I'm not going to like what you're going to say because I just don't understand. Having intelligence means your intelligence isn't intelligent enough to tell you to be intelligent. I think it should be. Intelligence can categorize and conceptualize complete nonsense. I don't see how that's true. That's exactly I'm counter-arguing that statement, frankly. That intelligence should make those kinds of errors impossible. If you're aware of the capacity to make the mistake, the idea is not to make the mistake. So if you know about your vulnerabilities or your weaknesses or your blah blah blah, then you should account for them logically. Okay. No way that makes any sense to me. That it makes you more of a phantasmagorical silly person. I think it should make you less if you have any kind of general intelligence. So if you're just saying the problem with intelligence is it can be very specific. So somebody can know a lot of shit about, the molecules of plastic and blah, 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 some kind of specific subject, and then they don't even know how to, not piss on the floor when they go to the bathroom. I mean, they could be missing something, a lot of other information, okay, that might be valuable to analyzing the circumstance, because all they know is specific details. They really don't understand the thing as a concept. So they're not really intelligent. They're just, well, that's the wrong way to say it. They have an extensive knowledge base, but it isn't well grounded is the word that comes to mind, but that's not the word I want. It's not complete. And the incompleteness can be profoundly important if what they're missing is, I can't run through a tree. So he doesn't know he can't run through trees. He knows everything about how to run, but he doesn't know he can't run through a tree. I mean, it could be a catastrophic bit of missing information. All right. A profound thing. Let's say your issue. No, we did that already. Okay, no subtracting. You just sum the momentum of the two objects post-collision, yes, which both remain positive because the whole air track setup has positive absolute momentum compared to the universe. I don't know why you're doing that. I mean, I don't know why you can't just recognize that whatever all three objects have the same motion in space. So what? We're talking about the fact that they are going to move different vectors. And again, I've already made this relativity argument. at every trillisecond, you're moving a different direction. You're not always moving in the same direction. You're moving in all kinds of directions. All kinds of forces are obliging this kind of motion in space, because you are in fact moving on the surface, and you are in fact moving through a direction, and you are in fact moving through the universe, and you're doing all of this compound motion. And that compound motion is built into you, okay, from some previous period when the gravity was strong or something. The Earth is moving because its velocity was acquired billions of years ago. Its velocity isn't acquired today. So this is all old motion that we all share. So we all have springs that are causing a resonant impact inside of us, a back and forth motion, you could say. And that's, but it's a motion that's going forward. So it's back and forth, but it started going this way, and so it continues to go that way. I don't know how to describe it, but anyway, it's not relevant, okay? Can't you just deal with the fucking experiment? It's right in front of you. I mean, this is just such horse shit. I mean, this is why, you can't have a logical conversation with people. The motions we all share, the pre-existing velocities, we can't get rid of them. We have them. The only way we can get rid of them is an opposing force has to take them away from us. We're doing an experiment, okay, where we're just going to have different objects that have the same condition in absolute space, and now we're going to create a new condition. We're going to give one of them a new force, all right? And that force is just going to move within that relative environment. It's not going to move into the absolute space. I mean, it's happening in absolute space, but it's not relevant because it's not going to undo what absolute space is already doing to you. You're not going to be able to undo the velocity the Earth got 4 billion years ago, okay, with an air track experiment. Anyway. The reason you call it 2 plus 2 plus 2 physics is undeniable. The reason you call it 2 plus 2 physics is undeniable. I don't know what that means. But yes, there's two kinds of force, two kinds of matter, two kinds of interactions. It's really 3 interactions, but I'm abbreviating it just for continuity of the jargon. Okay, it sounds better to say 2 plus 2 plus 2. But technically, okay, yes, there's a absorption of the energy, a reflection of the energy, and then there's the trick of converting the energy into the opposite force. So you could say it's 2 plus 2 plus 2 plus 1. Yeah. You could do the air track experiment in a semi-truck going a constant 100 miles an hour and get the same results. Yeah, so how is that remarkable? I guess I just don't understand why you're saying it matters, this frame crap. And it's not the absolute universe that's in the fucking experiment, in the sense that whatever you're subtracting is subtracted from some real force that the thing already has. So it's not going to change anything. There's no reason to blow up the absolute universe to believe in the relative one. The relative one is real. The absolute one is real. The fact is we can't see the absolute one because we're all moving. If the whole universe was moving 100 miles an hour in a pickup truck, okay, we'd never be able to know it. Except with the light clock, of course. So it can't go 100 miles an hour. It has to go fast enough where we can take something that's a constant, like the speed of light, and use it to show us the absolute universe. But photons are more complicated than people think they are, so you can't really do the light clock because you start breaking the photons. As you go faster and faster, you're not going to get photons anymore. You're just going to create bits of force. So what we need is a bit of force collector. So the photo multiplier is a kind of an interesting device because you can make it extremely sensitive. So it sees photons when we don't think there's any photon there. So you could almost argue that maybe it's a neutrino detector, right? That it might be able to detect the pieces of a photon. And that would be an interesting, if that's what it could actually detect, is a piece of a photon. Oh, I mean, well, you're just... my problem with it is it's imaginary energy. There's no fucking... First, there's no fucking such thing as negative momentum, and they're using negative momentum to say somehow there's conservation of momentum because something went this way, and I could subtract it to the thing that went that way, and you can't do that subtraction. You can't do that subtraction in space. It's fucking free energy, and it's stupid. I mean, to sit there and try to say that this is about semantics, this isn't about semantics. This is about a real fucking experiment where the end result of the experiment is there's more momentum in the universe. Oh, you fuck. You're getting to be such a cunt. Because there's no negative momentum now. I just, fuck you. Fuck you. There's negative relative energy, okay? You're taking one thing that's moving this way and saying somehow it completely undoes what goes the other way, and therefore there's no momentum in the universe. It's idiotic on its face, fuckhead. There's no extra momentum in the semi-truck. What the fuck are you talking about? I mean, how the fuck can you fuck this up, you fucking moron? I mean, this is not that fucking complicated. I really have to draw it just for you again? It's a really simple experiment. You're doing this. You're moving this at a fucking mass and a velocity relative to all the other pieces in the experiment. So all the other things in the experiment are in the same fucking opinion about what this is fucking goddamn doing. It's moving a fucking goddamn velocity and has a fucking goddamn mass. And you're banging into another fucking object, and that fucking object is leaving with more fucking momentum than this fucking object even had. And they're saying it's okay because this reflected in this direction with this amount of energy, and those two subtract, and therefore it's the same momentum. When obviously it's not the same fucking momentum. Obviously, if I go this way into the box of the experiment is in the back of your fucking pickup truck, and I push this into this thing, okay? This thing pops out with more momentum than this one in. That's called free fucking energy, retard. If you're making more momentum, you're making more energy, jackass. There's no other fucking way to look at it, fuckhead. Oh, god damn it. This is what your convention, your conversation in physics boils down to, and anyone leaves you insults and yelling. Well, gee, you can't even fucking write a sentence, you fucking piece of shit. Everyone has to walk on. Why? Even if I called you a motherfucking skanky badger shit, even if, it doesn't matter what the fuck I called you. Are you that big a fucking goddamn baby? What did I do? I hurt your feelings or something? What the fuck is your problem? I don't give a fuck if somebody calls me all kinds of goddamn names, okay, as long as they're not making direct accusations that I molest their children or something. Who fucking cares? You care because somebody calls you an asshole? I didn't say you stole money from your grandmother. What specific accusation did I make that is all that fucking outrageous? I'm just saying that clearly the Tim Johnson guy is just trying to rationalize something that can't be rationalized. The experiment speaks for its goddamn self. They're producing the experiment, they do the experiment, and they create what is fucking free motion in the universe. No doubt about it. And I'm supposed to say something other than, what the fuck? Can you please follow along? The experiment has to obey certain rules, okay? Either there is free energy or there's not, okay? There's no other way to interpret it. But all this baby talk, all this little, you come here with this stupid screen name K, and you make a comment like somebody's supposed to pay attention to some moron who has a screen name K. I mean, could you just write Troll K? I mean, you know, could you be more obscure, okay? More of a hider What are you hiding from? What's your fucking agenda on the internet? Whiny defense of insufferable stupidity? Is that your slogan? We make whiny defenses of moronic idiocracy. I think it's muted. I didn't mute anything. I think you're muted. Testing. Can anyone hear me? Apparently they heard my insults. They got all whiny about them. Let's see. We'll go to the live thing. No indication of it not working. Let's see. Analytics. 13 people. Okay. So what's the problem? So does anybody else see a problem? Just curious. Hear a problem. Come on, there's 13 of you. Somebody can say, I can hear it. Yeah, so, well, I know. Never mind, it's my phone. Yes, of course it was your phone. You should be sure. You should check all of those things. That's the first thing you should do, is check your phone first before you say on a comment section, you're muted. Yeah, but whatever. You're learning. Jeez. Everything works except your brains. But it is strange that you have to, I mean, I didn't explain the Professor Lewin experiment in this video, but I mean, I have. We've been over it so many times. And it just seems like, I really shouldn't have to go over it again. It's basically a free energy. I could do the experiment over and over again, and I could just keep increasing the momentum going in this direction. All I did is put energy in this direction. I increased the momentum. I do the same experiment again, I increase it again. I do the same experiment again, I increase it again. And then all I have to do is put it on a lever and bounce it back the other way, and I could just make myself a circular, perpetual free energy device. So obviously it can't be true, because I could exploit it as an experiment. I could exploit what it does, and I could convert the extra momentum it makes, and I could just do it over and over and over and over and just keep making more and more energy. Increasing the momentum 33% each time. Well, 66% each time. If I collected both directions. I'm just saying if I just collected the extra in one direction, it's 33%. I mean, it all comes down to, again, if they just did the simple thought experiment, if they just did this, a physicist just points out, I have a gun in space, in my rocket, and I have two choices. I can fire the bullet, or I can fire the gun into space. So I can either collect the bullet in my ship, or I can collect the gun in my ship and let the bullet out. What are you going to argue? That if I let the bullet go out, I only get 2 joules of turning power, but if I let the gun go out and keep the bullet, I get 2,000 joules of turning power. I mean, joules are watts. There's a wattage of turning power. Do I really have to defend the argument that, no, if I do that experiment in space, my spaceship is just going to end up back where it was? I mean, the bullet's going to turn me just as much as the gun, and I'm just going to end up being with the same vector I had to start with, because it's the same energy. It's the same thrust. NASA knows it's the same thrust. They could land on the moon, literally, shooting dimes really fast and 2-liter bottles really slow. They could actually have a lunar module that'll land on the moon by throwing masses out of the ship. And if your kinetic energy theory had any viability, wouldn't that have some effect? How can I make 2,000 joules and I don't create any 2,000 joules of opposite reaction? Where's the 2,000 joules worth of opposite reaction? So you really don't believe in Newton's third law. I mean, why don't you just say it? That your answer to the thought experiment, Tim, there's a simple thought experiment. I fire the gun, the bullet goes out. I let the gun go out. There's 1,000 times more joules going one way than went the other way. Does my spaceship turn? In the 100-mile-an-hour semi-truck, oh fuck, he's just going to keep doing his relativity crap. So the whole universe is moving 100 miles an hour that way. Somehow the experiment is different now. No, it's not. 2 mass goes 100 miles per hour, so again, you're just denying my whole argument that every trillisecond you're moving a different vector. So you just ignored that argument entirely and just aren't going to pay any attention. So you can't do this plus and minus some collected velocity over time. You're measuring the truck's motion over time. I'm arguing that in the time the collision takes place, the truck isn't just going this way, it's doing other motions also, okay? Because we're using a real universal truck here. We're not using one-directional trucks. As pointed out by you, by me, by anybody, you're moving on the surface of the Earth. The Earth is moving through the fucking goddamn galaxy, okay, at another tremendous speed. So why the fuck are you talking about how fast the Earth is spinning? That's not the motion of the Earth. The surface of the Earth is doing a lot more motions than that one. So this whole thing is just such a pile of crap. All right. If post-collision 2m goes 102, then by conservation, 1m has 99 for a total of whatever, 303 in both cases. I don't know what that even means. MV equals 303. I don't know what that means. I don't know. You made even more momentum. 2m goes 100 miles an hour, so by mv of 200. And 1m approaches, whatever. I get the mv as momentum. I don't, you're just, whatever this thought experiment's purpose is, I'm saying the premise of it is wrong, because your absolute velocity isn't the surface of the Earth. Your absolute velocity is a much more compound velocity, in a much more compound direction. So it's moot, in my opinion, for that reason alone, to pretend you're just going to take one velocity that you have and say that's your absolute velocity. And again, I'm saying these relative comparisons in that context just don't have anything to do with the experiment. We already know that the real world works a certain way. All the other experiments prove it works a certain way. Okay, bowling balls don't just fly off the alley. All kinds of things don't happen. So we know that's not a factor. So I don't know why you're doing this exactly. You want to make some complex relativity problem out of a simple experiment. I don't want to do that. I mean, the purpose of this video is to prove that this experiment was a lie and a fraud. That's the point of the video. The point of the video isn't to sit there and somehow resurrect it by making some sort of distracting relativity argument where I'm okay to argue relativity in a relativity video. But that's not what this video is. This video is demonstrating that this is why physics is broken. It's because liars get defended by jackasses like you. That's what essentially you're doing here by distracting the subject to some sort of relativity argument. Somehow relativity fixes it or breaks it or does something to it. Doesn't do anything. Doesn't have anything to do with the subject. Ugh. I mean, what he's trying to argue is, look, the Earth is moving this way, right? So we're going to assume the truck or whatever is moving some way relative to the Earth. So he's just using the truck's motion now. And he's saying that's the absolute universe, and the truck is moving this way. And now when I move things, I'm moving slower than the truck or faster than the truck. Okay. And so how does this change the experiment any? Because we've already all agreed since Galileo that the experiment isn't going to change because the truck is moving. Because all the pieces in the truck have the same velocity. And so yes, you're just plussing and minusing a pre-existing velocity. But you still have to always account for the momentum. So what's the difference? Their assertion is plain, that kinetic energy doesn't play by these rules anyway. And that somehow the energy going that way, okay, is acceptably understood as compensated by anything that happens the other way. They're just reversing the roles. We know that momentum is the one conserved, and that kinetic energy is the one you can finagle. Professor Lewin said the words. You can finagle, you can fuck with, you can something kinetic energy one way or another, but nature can't finagle momentum. Because your problem was negative momentum creating extra momentum in the universe. It's not my problem, shithead. You can't undo the momentum. So again, you're saying that because it's absolute velocity in a pretend experiment that never took place, okay, that somehow you've undone the idea that you're saying that in one case I'm losing real momentum. So when I'm actually rolling the truck, it doesn't have momentum relative to the truck. The experiment's happening in the truck. It's not happening in, theoretically. Let me see how to put that. You could argue that the thing you put in didn't have any extra momentum because it was going in the opposite direction of the truck. So if I just make the initial motion in the opposite direction that the truck is traveling, then you could argue it has negative momentum. But we know it's not going to be negative momentum because we know it's going to do the communication thing with the other object. It doesn't really matter which one you call negative motion and which one you call positive motion. That part doesn't matter. The idea that the motion itself, the mass and the velocity, that somehow you can create more of it is the argument. I mean, in theory, you're saying I could start with negative momentum. That is, I'm going in the wrong direction, so I'm going less than the speed of the truck. It doesn't mean that the object doesn't have any momentum. It clearly has a momentum different than the object that's going to hit it. So which one we say is standing still and which one is moving, does it really matter? All we're saying is that the total mass moving after the experiment has to be the same as the total mass moving before the experiment, when you can't take away any of its absolutes. You can't undo the absolutes because the thing you've added energy to, obviously you added it to its absolute. It couldn't be noticeably different. If everything's standing still because we're all moving the same, and I move something different, relative to the things moving the same, this has to be considered more. Can't be considered less than what these all three share. This has to be something different than what they have. Yeah, different. So whether they're moving into it or it's moving into them, the point is they're going to communicate and share their masses and velocities, and that number has to be conserved. So it doesn't matter whether these are moving or this is moving. Well, it does matter because this has more mass. More total momentum. All right, how to explain that? Well, you just want to have a relativity argument. Again, the point is that we know that the experiments always come out the same. So it doesn't matter how the game is played, the internal environment, everything is stuck having a shared momentum, and you can't change that. And I would argue the reason why you can't change it is because it's not what you think. It's not in one direction. And so that's not actually happening. Alright, because your problem was negative momentum creating extra momentum in the universe. Well, whatever. You're not dealing with the subject, so you're really just annoying the fuck out of me. Okay, the subject is whether Professor Lewin's experiment was real or a fraud. Alright, and apparently you don't have enough guts to take a side on that. And that's what I'd rather you did. The experiment on its face creates more momentum going in a direction. That's the on its face results, which is an aberrant result in all of science. So all of physics says that doesn't happen. I can't make it have more momentum in a direction. I can't do an experiment that creates more momentum in a direction. All right, that's what every other experiment says in the history of mankind. I can't make more momentum. All right, the experiment does. I'm saying it does because he cheated the fuck out of it. Okay. And you're saying this crap instead of saying, yeah, that's really bad for science. Okay, well, you link me to those better copies, because guess what? We viewed them all already. Okay, and every fucking one of them is flawed all over the place. So the one with the high school teacher, in my opinion, wins because she wasn't even trying to do the experiment. She wasn't doing the actual calculation. She was just demonstrating the experiment. And she demonstrated basically perfectly. Okay, in terms of the results, came out quite consistent with the conservation of momentum. Okay, I'm glad. I'm glad you think, okay? You're just showing me that you're an imbecile. So in spite of the fact that I just showed how the cart can't possibly weigh what Professor Lewin says it weighs, can't possibly be half the mass, all right? And you're just ignoring that information and saying, no, the experiment was real and it's valid and he made free momentum. So all I can say to you is, fuck you. That's just a desperate defense of absolute rubbish. You won't call them out on anything. You're never going to say your physicists are liars or cheaters. You're never going to say their physics is under evidenced. You're just weak. You're a dupe. Yeah, we've already seen it, asshole. So you think you're going to be linking to something new? You're not linking anything new. We've been to every one of these fucking videos. So everybody who's been here on this channel for a while knows this is going to be exactly the same video that we've already seen. Nothing new here at all. Okay, it's just going to be the same piece of shit that we've seen before. And we have to endure the ad, of course. So what time did he say I have to go to? God, you're just such a fucking... You're such a cunt. Anyway, let's see. What time? 1 minute and 20. Oh, well, that's not that important. Yeah, so we've seen this. So he thinks this is a well-done experiment. I mean, obviously it was like 6 months ago that we played all these videos. Yeah, we saw this one. So these are two even carts. What the fuck? We have to wait till we get all the way to the other cart, the heavier cart. We're not doing that. There we go. So we're just told, okay, masses. So where did this prove anything? All right, and right off in the face, I can make the same argument, right? We know this cart is a half-mass cart, right? I mean, it's cut that way, right? So this cart is half the size. This cart is half the size of this cart. So we can say right on the face, we know there's not 4 springs on this other cart. Doesn't appear to be any springs on it, actually. So that's not a good sign right on the face. Now, all you have to do is tilt this thing a little tiny bit and the results are going to be whatever you want them to be. So we don't get to see anything. So we have to do the frame rate thing. We have to take this video and we have to cut it into frames and then we'll find out what the real answer is. Okay, so she bangs it in and it leaves with a velocity. Now it doesn't appear to be 2/3 the velocity to me, but we'll see. Alright, so I'll download this and then I'll do the frame rate. But again, it won't tell you much because we really didn't see whether this thing was perfectly level or not. So that was interesting, right? The big cart stopped entirely, okay, dead in its tracks, so the other cart bounced off. So that was a little bit interesting. So it had the same momentum, right? See that again. Yeah, it stops dead. So it has to have the same momentum to stop dead, right? Okay, but anyway, fine. Alright. So that isn't a bad demonstration, except we don't get to see anything about how these were measured. You know, these velocities aren't, you know, it's not shown. So we have the masses, but we don't have any velocity information at all. So you're telling me you know what the velocities were of the carts. Okay, obviously he doesn't know that. So I really don't want to, you know, I don't know if I want to argue all of these, the other videos in this video, but I mean, go find the one with the high school teacher. What the hell was that called? Something air track. It was some demo of an air track. Demo something air track. You know, and, you know, a woman. And, you know, she does the experiment and the clocks are on and all that kind of stuff. And so, you know, and the results come out. If you understand that if you understand how she measured it, you know, the little catches of what she was measuring, you know, the results came out consistent with conservation of momentum. But you can't theoretically admit that it's a problem if you have an experiment that creates... where the hell did... Oh, damn. I don't know. I don't know what I did. I guess it doesn't matter. It seems to be working. Alright, so we just put the chat thing back. Alright. So you really think it's possible to create free momentum in a direction? You don't have a theoretical, like right on its face. Your brain doesn't just say, theoretically, yeah, that's a problem. I can't figure out how I could possibly increase the momentum going forward. You can't understand how I could just redo the experiment with just a heavier mass, heavier mass, heavier mass, heavier mass, and just do it 7 times in a direction, and then just use a lever to convert and go right back in the opposite direction with a lighter mass. Alright, let's see. Someone did the velocity frames, but it's someone who was arguing against you. I can link you if you like. Well, sure, go ahead and link to their fucking calculation. I'm just saying that we don't get to really test any of that experiment, right? So what part can you be sure of? And I'm just saying it's a pretty bold statement. I'm just saying, you're saying it's okay. It makes sense in your physical world that you have a certain amount of momentum. You can hit something, make extra momentum for free, okay? And going in that direction, it's going in that direction. And that somehow that's not a problem. You've got more momentum in the universe going in that direction. And you don't have to add anything. You don't have to do anything. You just get it for free. You don't see any problem with that. You can't imagine that you could collect that energy. That some free energy nut could easily collect that energy if it existed. If this actually happened, what you're claiming is a valid experiment actually happened, you're telling me you can't imagine how somebody would exploit that? It's not free momentum because the small car reverses direct. Again, you keep saying it. I'm saying just forget about the small car. What the fuck? I can forget about it if I want to. You're making free momentum in this direction. It's just a fact. Extra momentum is going this way. How can I not be able to exploit that? You're just evading the question entirely. You've got more momentum going this way. This goes in, I get that out. Who cares what else I moved in the universe? How could the fuck that be important? It can't make any difference. I'm just going to collect this stuff going this way. That I can do. I hit in, it pushes something out. It's going the same way that that was going, and it has more momentum. Well, why don't I just keep exploiting that? I mean, come on. Well, again, you're telling me you can't imagine how it could not be exploited. I'm just asking you to use your imagination for a little tiny bit, and you're telling me all these free energy nuts out there couldn't exploit that fact. If it actually happened, if the pen, I put the pen in the magic circumstance, the pen pops out with more momentum. You're telling me that some free energy nut can't exploit that. I could. Too stupid. I mean, too dishonest. Like I said, you can't imagine that that would be exploitable. I have an object goes in with a certain amount of momentum. I have an object coming out with more momentum in the same direction. And you're saying you can't imagine how that's exploitable. Electrons' repulsion creates a force that gives both objects a equal momentum in the opposite direction. So again, it's just more momentum is okay. I can make all the more momentum I want. I mean, I just can't believe you people. You will have to lose mass to gain that momentum. So it doesn't matter that I start this video showing you a cheat. Clearly, Professor Lewin cheated to make the experiment work. He couldn't make it work honestly. So he had to cheat the experiment to make it work. Because it won't work, because it's theoretical nonsense. And you're just ignoring those facts that I pointed out, that there's no way it could be half the mass. There's no logic to make it into a half mass. It just isn't logical to think that those mass numbers were right. So in spite of pretty much providing what I think would be enough evidence in a courtroom to convict, you won't even say there's a doubt. You won't even concede, well, there's good reason to doubt that was a legitimate experiment. You won't even concede that. You're just showing your fanatics. The cost, it cost energy to run. Now he's talking about the air, how much it costs to run the air track. What does that have to do with it? And I've pointed out before, that's the big flaw in the air track, is that it's actually putting more energy into the experiment. That is a little bit dangerous to get a condition of the nearly frictionless environment. So what does that have to do with anything? We can create low friction lots of other ways. So, I mean, frankly, I can swing the things on a pendulum and I should get exactly the same results, right? I don't have to put any energy into a pendulum, do I? No, I don't. So that's the experiment I actually did in my basement here. I made a ballistic pendulum, redid the experiment. I didn't get any of this free momentum. So, so you're not doing much thinking here. This isn't just an air track experiment. This is an anywhere in space experiment or anywhere on Earth where you've eliminated substantial amounts of friction. And they have to be substantial. Let's recognize this is 33% more energy. It's not a small amount of extra free energy in the one direction. And it's 66% more energy if you take all of the energy, if you collect all of it. So these are huge amounts of energy. So even if you have a frictionless environment, a friction environment, you know, what, friction could steal 15% maybe. You'd still be free 15. Alright, well, I'll watch the link later. No point in advertising moron channels. Yeah, well, we'll see. I'm just saying, and you don't, I'm just saying, right on its face, he gets 2/3. So in spite of what Professor Lewin said in previous videos, half the mass, twice the speed, it has no choice, nature can't finagle momentum. So in spite of that statement, you still have this confidence that, oh yeah, no, you can make free momentum, no problem. I just amazing. Yes, it was bouncing backwards. But the one going forward was going less than half the speed, okay? It didn't go 2/3 the speed. The twice as massive object didn't go 2/3 the velocity. It went less than half. Brozo did it on the air track without springs, and it didn't work, okay? So let's understand, you can only get it to work when you put springs on. So even though the aluminum, it was hitting the aluminum, which is supposed to be pretty elastic, right? Hard aluminum against hard aluminum, supposed to be pretty elastic. Didn't work. I mean, if the small object stopped in place, I totally agree with you, the two mass would have a velocity of 50%. Yes, and so it can't do more than 50%. You're saying it can do more than 50%. How does that make any sense to you? I mean, it's just amazing. Just amazing. You really think that there's... Okay, I mean, I gave you the example. I have two balls here. Two cue balls, two billiard balls. And I shoot a ball in here. By your theory, right, if I put these two, so I just glance this one this way and I glance that one this way, I won't lose any momentum. I can hit both balls, move them both in a direction, and I lose no momentum because they don't have any momentum. They subtract from each other. It's undue energy. Whatever I lose hitting this one this way, I gain somehow hitting that one that way. I mean, how do you make sense out of this crap? You say momentum must be conserved. How are you conserving the momentum? I'm just giving you the argument. You can't conserve, you can't possibly believe that you can keep increasing the momentum in a direction. Okay, the universe is constantly increasing. Let's just say I can make the mass heavier and heavier and heavier and heavier and heavier. And I just redo the experiment over and over and over again. I keep making preposterous amounts of fucking momentum in a direction. How can you possibly say you're not making free momentum? I mean, it's insane. How you're conserving momentum. You're not conserving anything. It's free energy. How is it not free energy? It's just as exploitable as you could say the rain cycle is conservative. But obviously, we're exploiting it hydroelectrically. We're exploiting the fuck out of the fact that in one direction it's easy to capture. You're creating a stream, essentially, a stream of momentum going that way. And you're saying I can't put a water wheel in it. And I'm saying, of course I could put a water wheel in it. Yeah, so what? And then I can just reverse it. Yes, I could go from 2 ounces to 4 ounces to 8 ounces to 16 ounces to 32 ounces. And then I could just bang that into a lever, put a lighter object 4 times the distance away and go back to a 4 ounce and then an 8 ounce and then a 16 and then a 32. I could just keep doing the experiment over and over and over and over and creating preposterous amounts of free energy. You will need to use, you meant to say. I mean, if you want to say levers don't conserve momentum, that's fine. Go ahead and say that. I mean, that's elemental to this whole conversation. I mean, it's the whole point of the conversation is that people will lie about levers, you'll lie about springs, you'll lie about pressure, or hydraulics, and you'll do this crap. because you won't take a stand. I mean, either you believe in conservation of momentum or you don't. And I'm just saying you cannot create more momentum in a direction. Anytime you create more momentum, it doesn't matter if there's 500 people running the other way. They don't undo the 500 people running this way. There's no undue momentum. Momentum isn't an undue thing. Well, again, I just did it. Ball here. I hit the ball into here. These two go off at different vectors that have negative components. I mean, reverse components. There's no way I didn't. There's no way this one's going 40. This one's not going 40, and this one's not going 40. They're going 20. I have to apportion the momentum. I can't sit there and say I can create extra in different directions. I can create undue energy. I guess I just have to do these videos in one simple little pieces and just say, if you won't take a stand on this one argument, then there's no point in having a conversation with you because you're belligerently stupid. I mean, it's the whole idea of conserving the momentum with the train argument, right? I mean, the 5-ton train, you put 5 extra tons on it, now it's a 10-ton train going half as fast, and you say it lost half its kinetic energy. And I say, how could it possibly lose any energy? It has exactly the same fucking momentum. And you're saying, well, it bent the metal and it made sparks and it made sounds and it did all this horrible stuff that lost all this energy. And I'm going to say, how does it do that without losing any momentum? How the fuck do you make a sound? How do you bend metal? How the fuck do you do any of that crap without losing momentum? You have to lose momentum. You can't keep the momentum and make sound. You can't keep the momentum and bend metal. You can't keep the momentum and make sparks. That's illogical. Foundationally nonsense. And here you are defending it. The larger mass won't be able to bring the smaller mass back to the same speed. So you're saying you don't believe levers work. Okay, so I'm telling you, of course, I can put a heavy object into a lever, okay, with a momentum close to the fulcrum. And then far away at the other end, I can put a little light object, and it'll gain proportional velocity. So it will conserve the momentum. Levers do conserve momentum. Now, you don't believe that? Fine, you can make that argument. You tell me levers don't conserve momentum. Say those words. Say the words so we have it for posterity. You don't believe levers have to conserve momentum. Go ahead and say those fucking words. And I'm going to tell you that, yes, you're completely full of shit, okay? Any engineer knows levers do goddamn work, and they will produce twice the velocity and the half-mass object twice as far, and if I use a quarter mass or an eighth mass or any mass I want to, and the motion will be perfect, okay? This will go slow speed, slow velocity. This will go very fast velocity, and the momentum will be conserved. So I will be able to restart the experiment with a light object and just redo it all over again, and then have the same lever do the same thing on the other side, and I can just restart the experiment over and over and over and over and over, and generate billions of megawatts of free electricity. All right, so just say you don't believe levers conserve momentum. Say the fucking words, Virgo. Be an honest person. Say, you sincerely do not believe levers conserve momentum. You don't believe there's any experiments demonstrating so, and that, yes, levers destroy momentum. They suck at conserving momentum. Say those words. They suck at it. They don't fail. They fail catastrophically to conserve momentum. 1.4 is all you get. You put a half mass, twice the distance, and all you get is 0.4 velocity, extra velocity. Nowhere near 2. 1.4. Say the words, fucker. Say you think that's rational. That's a rational belief you have. I mean, theoretically, you just put it on Newton's cradle, right? I mean, all I have to do this experiment, I take a small ball, bigger ball, bigger ball, bigger ball, bigger ball, and I put the energy in, and I automatically get more momentum coming out. Levers won't be able to bring, so he won't say it. He's going to just keep evading the statement. Levers won't be able to bring the small mass to the same speed. So we already said that. Okay, so it's just this. I don't know what that even, Yeah, no, it's the same thing. Nothing changed. Sorry, I thought it was a new comment. I thought I saw something move, but I guess nothing moved. So he did put a new comment saying the same thing. Levers won't be able to bring the small mass to the same speed. It's not the same speed. A half mass goes twice as fast. A twice as heavy mass goes twice as slow. Are you retarded? I'm just saying, we've been over this so many times. I mean, I have a lever. Here's the fulcrum in the middle. I put one mass here. I put a half mass twice the distance out here. Your theory is that this doesn't conserve momentum. This won't leave at twice the velocity, even though this velocity has to be twice the velocity. I mean, this motion has to be multiplied by 2 here. There's no way to undo that. You can't have motion here, okay, that this motion isn't twice the velocity here. It's impossible to have it come out any other way. You keep saying, okay, so you just won't say the statement, okay? If you're not going to just answer the fucking question, if you're not going to say it, then I'll block you, okay? So just say, you don't believe levers conserve momentum. Say it. I want it on the record, fuckhead. So say it or you're done commenting here. Say you don't believe in conservation of momentum. You don't believe levers conserve it. You don't believe gears conserve it. You don't believe pulleys conserve it. You don't believe hydraulics conserve it. You don't have to conserve momentum. Say it! I suppose shooting arrows at a pumpkin on a pendulum, whatever. Dull arrows are pointy arrows. Any arrow that has the pumpkin converts its kinetic energy into gravitational potential energy. I don't know of what value this crap of a statement is. Capturing velocity isn't that simple. If it was really simple, then we'd all be able to do it well. It's not that easy to do. Okay, capturing something's velocity in the same direction it's moving without it getting converted to any heat or friction or any other kind of crap are experiments that they really should be doing on the space shuttle, okay? Because there's no way to do it here. I mean, it's difficult. Okay, so you're fucking full of shit. Momentum is conserved. It can't be conserved if the velocity for the half mass isn't twice the velocity. Then you did not conserve the momentum in the lever. So you're just lying. I mean, you're just proving you have no interest in having a rational conversation because you're going to break the fucking rules of a rational conversation. Obviously, if it leaves with 1.4 the velocity and it's half the mass, it didn't conserve the momentum. You don't know what conservation of momentum means. It means the mv times that fucking equation has to be the same on both fucking sides, jackass. It means if you have a one mass going twice the velocity going on one side, you have to have a half mass going twice the velocity. I mean, well, you know the inverse relationship. The two MVs have to have the same fucking number. The outcome MV has to be the same number as the input MV. That's how you conserve. If you're doing 1.4, you're not conserving, fuckhead. So again, if you're not going to say the damn statement, then just get the fuck out of here. Voluntarily disappear, because I'll make you go away. Because you're just proving you're a lying sack of goddamn shit. I have to answer your questions. You won't say a goddamn thing. You won't put your reputation on the line at all here with this wishy-washy, mushy talk about how I can conserve it here and I don't have to conserve it here and I can break it rule here and it's inertia. Inertia. Fuck you. You either believe in conservation of momentum or you don't. That's a fact. And you clearly don't, because you're telling me a lever doesn't work. The Earth took the momentum. Fine. You're saying levers don't conserve the momentum then. Anytime you're leaking the momentum, it's not called conservation of momentum because you've lost it to some place. Okay, jackass? We're not talking about that. We're saying, does the lever itself produce a conservation of momentum? That is, you put energy in, the lever gives you back the energy. Not that it gives it to the goddamn Earth. That's not a conservation of momentum statement. Your magical, I didn't measure it, but it went into the Earth. So somehow the lever found it more difficult to push the lighter object. And so more energy went into the Earth because it's harder to push the lighter object. Okay, good. He said it. So levers don't conserve momentum. Great. Okay, we got the statement. That's all I want. So conservation of momentum isn't a real thing. So nobody should even say it because it's not a real thing. You don't have to conserve anything. You can bend metal without using any momentum. You can make sparks without using any momentum. You can make sounds without using any momentum. Because it's all magical. Magical energy does it. No, you're just saying so. Okay, you have absolutely zero experimental evidence showing the lever got heavier when the half mass tried to be ejected. That somehow the lever got heavier. Okay, you have no evidence of this fucking phenomenon taking place in the real world. You're just making it up. So fine. You've told us all. All I needed you to say was, so levers don't conserve momentum. There you go. That's all I need from you. That's it. That's the statement. Okay, I don't need any more than that. Bingo. We've got you. How come the chat isn't visible? That's strange. Yeah, really strange. Should be visible. It's on the screen. I wonder what the hell's going on. Alright, let's try this. And then we'll try that. Oh, that didn't work. Oh, it's behind me. That's why. Yeah, I couldn't see it behind there. Yeah, whatever. The net momentum is conserved. It's just baby talk. So I've saved this. That's all I need from you. So levers don't conserve momentum. Fine. I mean, it just proves I am arguing with a flat earther, okay? I mean, somebody who doesn't really take physics at all seriously. So even though Professor overtly tells you nature can't finagle momentum, you're going to make up this nonsense that somehow it can. I mean, I can change the experiment into some other experiment using some other similar to a lever device, right? So I've already pointed out the hydraulic problem. So there's no way around it, frankly. So I have... I have two cylinders, and I have one cylinder on the other side. Let's just say they're all the same size. And I can push these two, tie these two together, and push hydraulic fluid with two cylinders. Okay, and they'll make this one go twice as fast because momentum will be conserved. I won't be able to undo that. I can go in with this one, and I can make these go twice as slow. Or I can put these in and get this one to go twice as fast. And it's a fact. And you're saying that doesn't happen. So instead of a lever, I use a cylinder. So I have a 1 cylinder over here and a 2 cylinder over here. Two tied together. Well, let's do it this way. So I have 2 cylinders tied together over here and just 1 over here. And now I'm going to drop a weight on one side. And the other one's just the 1 cylinder. So I drop the heavy mass onto this one. I have the light mass on top of this one. So the heavy mass is going to push on this one with a weight. And this one isn't going to leave with twice the velocity, is your argument. I suppose you can make the same argument. Somehow friction, it just somehow goes into the earth. Well, why are you doing this pumpkin thing? I don't know. Well, anyway, let me just do this other one. Let's see. If it was prevented from moving, it would weigh more. So again, all you're arguing to me is that the same as the spring argument. You're saying that if I compress a spring and I put a lighter object on it, the spring has a harder time pushing the lighter object and loses energy going the other way because it's hard to push the lighter object. And I'm saying, no, it really isn't. It isn't that much harder. I mean, obviously, faster velocities are always difficult to create in nature. I mean, you have to organize the energy and have it go in one direction. Organized energy is more work than unorganized energy. But it's not enough to destroy the fact that springs conserve momentum. Okay, and that a certain amount of weight on a spring is a certain amount of weight. If I step on a scale, a spring, and then we lock the spring at that location and we put somebody who weighs half as much on top of the scale, it's going to return the momentum. It's going to conserve it. All right, back to the air track. When the big car reverses the direction, no, this big car doesn't reverse direction. Reverses the direction of the small car. Well, whatever, you're saying that's what happened. But anyway, why the small car goes backwards isn't because the big car did it. How could the big car do that without acquiring the momentum needed to reverse the small car? Well, because you're the one saying it reversed the small car, and that somehow that takes extra energy. I'm saying that's just a portion of the momentum. That's exactly the point. When I did the experiment, that's exactly how it comes out. The heavy mass goes less than half the speed, and the other mass moves away with the remainder, conserving the momentum. I don't know. He just keeps going round and round. He won't stick to the subject. The subject is free momentum. I was saying, and how I just pointed out how I could exploit your experiment. If it actually really happens in the world, I can exploit it. I can make a free energy machine. It obviously doesn't work because we would have free energy if it did. If your theory worked, we'd already have free energy, frankly. I mean, it's just, I was saying with the pumpkin pendulum experiment, the arrow's momentum is conserved into ether. Yeah, well, so you're just saying that you're going to do an imaginary experiment where all the energy in one direction is collected by the pumpkin and that the arrow doesn't do a bunch of work breaking the pumpkin and smashing pieces and all that kind of crap. Fine, okay, so you're doing a thought experiment about a magical pumpkin exchange. Well, yeah, then all the momentum has to be exchanged in the right direction, then we don't have a problem. But we can't do that experiment, so what's the point? We're looking for physical evidence. I mean, it's nice to make a logical statement, like where did the energy go, right? So yes, you're saying I shoot the arrow into the pumpkin. If the pumpkin theoretically collects all the energy in the one direction, how does the pumpkin not conserve the momentum and move off? But you're eliminating all the variables that they wish to exploit to say it magically disappeared as sound and it magically disappeared as some other thing. So anyway, this argument was worth having just because it makes me refocus that I really can't expect people to be at all reasonable. And they're just going to keep trying to defend. So even though, again, I showed the Professor Lewin flaws in the experimental setup, And they won't, not one concession that, gee, there really shouldn't be clay on that cart. And, it really doesn't add up and it looks bad. They won't even say it looks bad. So they're never going to catch their physicists. They're never going to stop them from cheating. Because they'll apply no scrutiny at all. No quick release, that's okay. No, have a bunch of springs with different constants. Who knows? Who cares? We don't care. The clay looks bad. There, well, that's one concession. But what if it was added so the weight exactly half the mass? Well, I just pointed out. But there's no point in making a logical argument. I'm saying there's no logic that can defend that. There's no 4 springs. There's no 2 detectors. There's no extra 2 on the thing that's supposed to be twice as heavy. If it doesn't have all those extras and have twice as many of them, it can't possibly weigh twice as much. And so it's not missing just 2 clumps of clay. It's missing 4 clumps of clay. It's amazing. So what exactly would the clay be compensating for? That the aluminum isn't cut to half the size? Well, that's a bullshit argument in my opinion. So where are you saying the extra mass it's compensating for is? Somehow it was underweight? So even though it has more springs on it than it should have, and even though it has more detectors on it than it should have, and even though it has more weights on it than it should have, it was somehow underweight? Man, you're just such a fucking piece of shit to defend all that. We have to assume that people setting up the experiment weighed the... I'm just saying, the whole point of me making the point is to point out how, no, what you have to assume is they wanted the results. They wanted to do a demonstration, and they didn't care that it didn't work. So they forced it to work. I mean, it'd be nice to be able to assume they're honest. My whole point of showing the video is to show you can't use that assumption. That presumption of innocence, okay, is very destructive because these are people who will fool you. So you have to sit there and say, I'm not going to presume them guilty or innocent. I'm going to scrutinize honestly. And I just pointed out how if you honestly scrutinize those 2 carts, I showed them sitting right there side by side. How can you honestly scrutinize and say, I think that one weighs half as much? If you honestly look at it without any presumptions and just say, how much do you think that little car weighs compared to that big car, you can't possibly logically conclude it's half the mass. It's obviously got to be more than half. I mean, I'm making the accusation that they're cheating, okay? It's not that it's an accident. The masses are a lie, okay? It's just a fact. They didn't care to keep any, to worry about it, okay? In terms of fudging it. And the lie is, and what I'm indicating, showing you as evidence of finagling, that finagling is completely consistent with the bias that would make the experiment work. If you do increase the mass, you do make it possible to create the illusion, okay, of the free energy, the free momentum. Alright, so I guess that's enough for today. So, Newton's cradle, using your free reflection of momentum, whatever that is, the metal ball would bounce off without transferring momentum. So, I don't know what you're talking about. Nothing bounces off with more velocity than the mass velocity. Always has to be conserved. And the amount of losses to the pendulum, to the air resistance, or the friction of the bearing, or whatever, are so minimal that they'll never show up in the experiment. So I'm never saying you can ever not conserve momentum. So you're just lying, using your free reflection of momentum. I don't know what the fuck that could possibly mean. If it's an elastic collision, okay, I bounce something against a spring. The spring returns the energy. Now, obviously there's some losses. I'm saying they're minimal, and you can get the idea that it's pretty conservative. And depending on how you do that, if you use magnets, for example, you'll get back a lot more energy because there's a lot less heat created. So yes, you have a negative magnet, north side, and you have a north side magnet, and you just swing the pendulum into the north side magnet, and obviously they're in a channel so they can't go crooked. You're going to get back what you put in. That's conservation of momentum, by the way. So just physics. Chores and depression is your life at this point. Okay, I'll just block you. Okay, that's absolutely useless crap. Obviously, I have plenty of life. I don't, 2 hours of my day. You think that's my whole day, 2 hours? Oh, fuck you in the ass till dead. I mean, there are like I said, there's just no point in doing that crap, right? We're having a physics conversation, the asshole has to inject some crap like that. Just useless. How many babies did you fuck today, fucker? Yeah, you baby fucker. Can you just use a scale with a spring as a way to show the force? Of course. I've already pointed it out. That's what I did. I just dropped things on a scale. You drop it from 1 centimeter, it weighs twice as much. Instantaneous weight. Doesn't stay that way, but that's how much it weighs. That's how much the pressure is. And then I go 4 times higher than the centimeter, and I double the mass again. The weight. Okay? Only double it. 4 times higher, double the weight. Right? I go 4 times higher than that, I'll double the weight again. Scales measure energy, because energy is momentum. Yes, that's my theory. And I'm amazed that it's not your theory. I mean, it just amazes me that people don't think it's that simple. But yeah, it's that simple. Pressure, weight, is energy. The metal ball that is moving would bounce off instead of stationary metal ball. I was going to keep arguing. What the fuck are you talking about? If it's bouncing off, it's using its own energy. Its energy is being reflected right back. There's no other source of energy. And what does it have to do with conservation of momentum? We're saying that we're going to conserve the MVs here. Something comes in and it goes back out again. All I'm saying is, yes, you conserve the momentum. Does it matter? You have some theory that there's some extra force that comes in this way and does something? I don't care if you think so. Because what does it have to do with the fact that this part was conserved? The thing has the same momentum. Are you saying it has no momentum because it went this way and then it went that way? That means it doesn't have any momentum in the universe anymore? No, the thing has motion. They don't just decide to turn around. It's a reflection. The energy goes into the object. The energy can't move the atoms. So the atoms go back to where they are in the heavy thing, and it just throws the energy back the other way. You pushed its atoms this way. The atoms said, no, we're not really going to go that way because we're too many of us. We're not going to be able to accept the energy, and it just sends the energy right back the other way. You moved the magnet. You pushed the magnet. and the other magnet said, I'm not moving. The magnet has to go back this way. It doesn't have a choice. It's in a field of force. So it doesn't just decide. If I move towards the sun and we thought about the photons being real force hitting me, right? Real pushing force. Well, obviously if I push into the sun and the sun doesn't yield, then the photons are going to push me back the other way. I mean, it's not that hard to figure out. I had to push against the photon pressure. I used the energy to push against it, and now it's just going to give back, essentially. Okay, the change I made, it's just going to undo the change I made. I made a change. It's just going to say, I'm going back to the way I am and give you back your motion. Give you back the change. I won't take the change. You have to take the change back. I mean, that's what you could argue, is something fails to change the other object. If it fails to change the other object, well, then the energy has to go somewhere else. That's the reflection. So I can propel myself. No, you can't. So you could just keep making up fake stories that somehow I said there's some way you could turn yourself around in a circle, I suppose. You could pull your own stupid tail. You know. But that's it. Yeah. So you could rotate yourself. Why would the atoms just decide to turn around? Yeah. So it's, you know, obviously that's not what I'm stating is happening. I've already pointed out to you specifically, I think yesterday, that energy is always a contact between energy, something moving this way and something moving this way, and it's always a reflection. And all you're saying is that if I move into something that doesn't have as much energy going this way, I can move the whole object. Let's see. Just throw things at magnets and my car moves forward. So again, just a lie. That's not what I'm saying. So again, just lie some more. Just keep lying. Obviously, I said you had to move into the sun. You had to use energy to push into the sunlight to get closer. More photons are hitting you. You have to apply a pressure. And then the pressure that exists in the sun is going to push you back. But what is it really doing? It's just going back to the condition it had previously. Retard. This isn't confusion. These people are belligerent assholes. Okay, so let's understand. There's no confusion here. I've never said you don't conserve momentum, and I've never said anything other than the energy is reflected. And reflection can be understood as always being a little bit complicated. Nothing just reflects, just turns around. It always has to hit something. Light hitting a mirror. There's a reason why the photon is reflected. Okay, now the argument can be made that it's a new photon that's going in a new direction. But the simple word reflection is valid in the sense that the energy is released. The thing the light hit goes back to its equilibrium state. And the energy is in the photon that leaves. So the energy, we can see where it's moving. So reflection with only one object moving. I'm just saying there's only one difference between the two objects, and now the difference is going to leave. The one thing will stay the way it was. It didn't accept change. It's just about change, right? You've got two things that have some different property. You're saying I'm going to connect them. The argument, simple argument I'm making is there was only one unit of change that went in, And it either is going to change this object and this object. They'll both be changed, and they'll go both off in a different direction, but it's still the same amount of energy, the same amount of motion, the same amount of difference will exist. And that's all you're saying. So either give all the change happens to this one, or all the change happens to this one, or they share the change. That's it. There's nothing else to my argument, fuckhead. I'm saying you have to conserve the change. Whatever's different between them has to be conserved. If they share it, and if this is going 40 and they share it, then this one's going 20 and this one's going 20. If they transfer it, then this one's going 40. If it reflects, then this one's going 40. That's all. Not complicated. Shit for brain. So reflection with only one object moving, more bullshit, are gaining momentum. There's no gaining, so more just lies, implying that I'm saying something other than that simple argument I'm making. There's a certain amount of change, difference between the two things. The difference must be conserved, period. So you can split the difference, one thing can take the difference, or the other thing can take the difference. The distance, the difference is conserved. There, that's a more explicit, more precise way to say it. They have a different circumstance, a different property in terms of their absolute positions in space, whatever. And all you're going to do is through contact, you're going to exchange the differences, period. And all you can have at the end is the same amount of difference. Well, again, you can say it resists change. I'm saying you have to give it. It has to be given. The bowling ball has to hit the pin and give it. The pins aren't saying, I'm going to resist being moved. They're not resisting anything. They're saying, give me your energy and I'll take it. You have 40 miles an hour, give me 20 miles an hour, and you'll have 20. Because I took it. There's no resistance. Resistance would imply an innate friction. There's no innate friction. There's no innate not moving. It's only on the surface that you have to push things with extra energy to get them going. That's in friction. There's no resistance to motion as long as you're not stuck to something. You're not going to resist moving. If I'm in space and I just do this, okay, to the space shuttle, I just do that. I'm going to get a hunk of the energy, and the space shuttle is going to get a hunk of the energy. It's just a fact that big things take longer to process anything you do to them. So any difference you impose on a big thing, if you're not going to impose it through a very slow process, it's not going to be able to communicate it to all its pieces and comply with your request that it take the energy. And instead it's going to have to reject it because it can't make all of its pieces move. So the heavier something is, the more energy it takes to make it move. I'm not into demonstrations, but whatever. So the one object resists change. I mean, maybe I can find a video that demonstrates a reflection, if that's all you need. Can you demonstrate this reflection without momentum given in the opposite direction? Okay, I'll use the brick wall again. I throw a tennis ball against the Empire State Building. Now, I only get back 75% of the energy I put in because that's how poorly elastic tennis balls really are. But let's say it was a perfect tennis ball. The energy is not going to be accepted by the building. That's the whole point. If the building yielded, then I'm going to get less out. The more the building yields, the more the tennis ball goes with the building. the less the building yields, the more the energy goes with the tennis ball reflecting. So the more wobbly I make the Empire State Building, let's say I make it really wobbly, I put it on a frictionless cart, and then I throw the tennis ball at it, the tennis ball won't bounce as far. So the more rigid the body is, the more perfect the reflection. Ah, fuck you. Whether I mention it or not doesn't matter, but whatever, fine. I don't need the change of subject crap. Fuck. I said I will or I won't or who cares? I mean, I might. Okay? Period. I mean, frankly, the level of conversation is so shitty. This is reminding me that, that will just be a nightmare. I'll just be blocking people endlessly because they'll just keep talking about how big my feet are or something. If you have a 12-mile-long metal rod in space, how long would it take for travel the movement to the other end of the rod? Well, this experiment's already been done. You don't have to be in space. It moves at the speed of sound in steel. So if it's a steel rod, an iron rod or whatever, it moves at a couple thousand meters per second, something like that. So the information goes from one end to the other end. It takes that long. The other end doesn't physically move. Okay. And it doesn't physically move at this, with whatever velocity you hit it with. And it just literally takes the speed of sound, time-wise, before the other end moves. The steel essentially compresses, you could argue, right? Absorbs the energy, and then the other end doesn't start going, okay? Until the electrons at the other end are told of what's going on, and they don't know what's going on until the speed of sound. It takes the speed of sound in the steel to inform the electrons at the end of the steel that they're supposed to go that way. And they will, in fact, go that way if you hit them with a hammer. But if you hit them with a feather, they won't. All right, so 2.5 hours. We're got to get going. All right, so anyway, thanks, I suppose. It's just really irritating, but this is the state of things. So at least we got one concession that clay doesn't look very good, and we got a concession that somebody doesn't believe momentum has to be conserved. So that's good. Levers don't conserve it. They don't produce it as a result. They don't produce conservation. I guess that's the way we have to say it, right? So it doesn't produce a conservation of the momentum because it has too much friction. It has too much waste, too many losses. It's too imperfect. Can you show us your simulation reflecting? Yeah, it happens every time something's moving this way. It has a bit of force connected to it and it's moving this way, and it hits a force going that way and it reflects. Every fucking time. So I just already did this. It reflects. You can't hit something that's moving the same direction you're moving. I've already done this for you. So if you're going to do it, if you're going to force me to say it a third time, then I'm going to, fuck you. So momentum isn't conserved. So again, you're just a lying sack of shit. You don't believe in momentum. You've already pointed it out. You don't believe you have to conserve it. And you're just using a made-up fable that you have some reason to believe the extra energy goes into the ground, and you have no experimental evidence demonstrating that. But in your simulation, the other object moved backwards is a lie. It doesn't happen. Sorry, that never happens. It always has to go through stop. It can never go backwards. It always has to go through stop. So just lie some more. Show us the momentum reflecting for free. So if you're going to keep doing this, then I'll just block you now. Right? I can block you later. I can block you now. I mean, what the fuck is this? I just explained. I can throw a tennis ball at a building and the ball comes back to me. How have I not conserved the momentum and I haven't added any other forces? I haven't taken any forces from the universe. You're just a liar. All right. Ugh, people, you just suck. Okay, enough of that crap. Alright, so till the next time and such. I'm just talking to lying pieces of shit. It's all the planet's covered in.